Here I will show you a very complicated real-world case of the Sichuan-Tibet Railway, which is believed to be the most difficult railway project on Earth. In this example, the linear distances between the two endpoints, that is the Luding and the Kangding. The linear distance between Luding and Kangding is 32 kilometers. However, the elevation differences between Luding and Kangding is 1,300 meters. The maximum along the gradients for railways are 20. However, the natural gradient in the study area is 40. Thus, this is classified as a very survey gradient alignment region. The major constraints and the terrain, three-dimensional terrain, are shown in this slide, as shown in the right figure. The terrain fluctuated drastically. The start point is around here, and the end point is around here. Thus, to build a railway by connecting these two endpoints, the alignment must be fairly circuitous to overcome the complicated terrain. The major results are shown here. Firstly, after 4,748 seconds scanning of the bidirectional DT, we found 45 promising passes in the study area. Then, the best corridor with the lowest cost is selected as the best path to generate a corridor. And then, the improved GA is used to find the optimized alignment with cruise sections in the best corridor. This is the final horizontal alignment, and this is the final vertical alignment. And we further compared the computer-generated best alignment with the best alignment designed by very experienced human designers in China. The pink line is the manual work designed by human designers, and the blue line is generated using our algorithm. This is the horizontal alignment comparison. We can see that the alignment must be fairly circuitous to link the two endpoints. And these are the vertical alignment comparisons. The alignment length, our computer-generated alignment shortens the alignment length by nearly 2.5 kilometers. And the tunnel, especially the expensive and overly long tunnels, have been shortened by nearly 6.6 kilometers. Thus, by reducing the expensive construction costs for tunnel sections, the comprehensive cost of the railway alignment can be reduced by 6.8% by using our algorithm.